Hi students, I'm Premier Sebastian Paul. In this lecture, we are considering the first example for the 4-variable K-map solution. So in the lecture number 83, we had discussed the rules for K-maps. These rules include pair reduction, chord reduction, octet reduction, map rolling reduction, overlapping group, and redundant group. And in the last 3 lectures, we had discussed the different examples for 3-variable K-map solution. So my dear students, in this lecture, we are considering a 4-variable solution. Our first question is, simplify the Boolean function using K-map. And the function is a plus b plus c bar plus d into a plus b bar plus c bar plus d into a bar plus b bar plus c bar plus d into a bar plus b plus c bar plus d. So as we can see in this equation, the given function has 4 different variables. Those variables are a, b, c and d, and all the individual terms has all these 4 variables. And here in this given function, the 4th and the 8th term is just repeating, and as per our Boolean laws, if a variable is multiplied or ANDed with the same variable, we can avoid the second term, or we can just write it as one time. That is, a into a is a itself. So we can avoid the repetition and write only one time 4th term, that is a bar plus b plus c bar plus d. And next what we have to do is convert these representation into the max term. That is, a variable can be represented in POS as 0, and a variable complement can be represented in max term as 1. That is the first term. A plus b plus c bar plus d can be represented as 0, 0, 1, 0. A plus b bar plus c bar plus d can be represented as 0, 1, 1, 0. A bar plus c bar plus d can be represented as 1, 1, 1, 0. Fourth term, a bar plus b plus c bar plus d can be represented as 1, 0, 1, 0. Fifth term, a bar plus b plus c plus d can be represented as 1, 0, 0, 0. A bar plus b plus c plus d bar can be represented as 1, 0, 0, 1. And finally, a bar plus b plus c bar plus d bar can be represented as 1, 0, 1, 1. This term 0, 0, 1, 0 is equivalent to the max term representation em2. 0, 1, 1, 0 is em6. 1, 1, 1, 0 is em14. 1, 0, 1, 0 is em10. 1, 0, 0, 0 is em9. 1, 0, 0, 1 is em8, and finally 1, 0, 1, 1 is em11. Thus, the function can be written as m2 into m6 into m8 into m9 into m10 into m11 into m14, and which is equivalent to pi of 2, 6, 8, 9, 10, 11 and 14. So my dear students, as we can see, this function has 4 different variables, so we have to use 2 raised to 4 different cells for a K-map. That is, 2 raised to 4 is equal to 16 cell K-map are using for solving this function. And the 16 cell K-map is shown in this figure. The rows represents the variable a and b, and the columns represent the variable c and d. So the variable a is represented in green color, b is represented in yellow color, the variable c is represented in red, and d is represented in blue color. And each and every cell has individual a, b, c, d values. So my dear students, now we have to mark the given function into this K-map. So here what we have to do is mark the given function, that is a pi function, into this K-map. That is, the given function is pi of 2, 6, 8, 9, 10, 11 and 14. So we have to mark the value 0 in the cell positions 2, 6, 8, 9, 10, 11 and 14. And the rest of the cells are marked with the value 1. That is, the cell number 0, 1, 3, 4, 5, 7, 12, 13 and 15 is marked with the value 1. And now we have to start our reduction. So we are applying the chord reduction rule for the cells 2, 6, 14 and 10, which lies in the 4th column and covers all the rows. And secondly, we can see an overlapping second chord, which is represented in blue color, with the cells 8, 9, 10 and 11, and it lies in the 4th row and in all the columns. Next, we have to write the max term equivalence of these codes. So if we are considering the first code that is marked in the red color, since this code lies in all the row, the values of A and B is changing, thus we have to avoid the values of A and B. And it lies in the 4th column, and the value of C and D in that particular column is 1, 0. That is, the value of C is 1 and value of D is 0. Thus, the final reduction can be written as C bar plus D. Since it lies in the 4th column, the value of C is 1, we are taking it as C bar, and the value of D is equal to 0, thus we are taking the value of D itself, and plus sign denotes the max term. And if we are considering the second code, that code lies in the 4th row, and the value of A and B in that particular row is 1, 0 respectively, and thus since the value of A and B is not changing in that particular row, the max term can be written as A bar plus B. If we are analyzing each and every column, the value of C and D is changing, and thus we are ignoring the values of C and D. So the final POS can be written as product of these individual terms or ANDing these individual terms, that is POS is equal to C bar plus D into A bar plus B. So my dear students, our given function was pi of 2, 6, 8, 9, 10, 11, 14, and the reduced form or the POS representation is equal to C bar plus D into A bar plus B. So my students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our question is, simplify the following Boolean function using a 4-variable K-map. The function is f of DEFG is equal to pi of 0, 1, 4, 5, 9, 10, 11, 14 and 15. So my dear students, hope you had understood this topic. In the upcoming lecture, we are discussing the second example for 4-variable K-map solution. So see you soon. Until then, goodbye. Thank you and all the best.